Hey there, welcome to today's video where we'll dive into a common problem encountered while debugging in C++. Picture this. You need deep in a segfault issue, trying to wrap your head around the memory layout in the core file generated when the program crashes. To get a better grip on using GDB for memory inspection, we're using a small program that intentionally segfaults. Now, let's delve into the solution. When you see 0x00000004 in the debug output, it doesn't represent the bytes 2000000004. It actually signifies that the next 4 bytes, when interpreted as a hex value, equals 0x00000004. Given your system is Little Endian, the actual bytes are 040000000, 0C0000000, 020, 140F9, FF7, F0, 0, 00 foot. Continuing with the solution, when you shift by 1 byte, the bytes are reorganized and reinterpreted as 0x0C0000000x 2000000x FF9 40 E10x C A00007F. It's all consistent with the data observation. Nothing bizarre like jumping forward bytes or strange Indianish shifts is happening here. In summary, understanding how GDB represents memory contents in Little Endian systems is crucial for effective debugging. By grasping how byte order affects interpretation, you can navigate memory layouts with more confidence. Alright, if you found this video helpful, don't forget to hit subscribe, like the video, and leave a witty comment below. Stay curious and happy coding.